Free response is good for like, remember related rates? Remember that? It's good to have one where you gotta, here comes the boat, what else do we do? The ladder falling and stuff like that, or maybe like a max min problem like we did earlier. Sound good? I'll do some more of that. Remember last Thursday? We didn't do it so much today because I wanted to get into this rule. Remember last Thursday when we go, we gotta find the actual relative maximum, we did the first derivative test. One of those problems. I'd say, find the relative maximums for this problem.
Oh, okay.
Does that make sense? Hey, cool. Everyone, just a couple more, okay? Try this. Just throw people off. Something about negative exponents drives students crazy.
So that's infinite.
I want you to take care of that daggone negative exponent right away. What does e to the negative x mean?
1 over e to the power x.
Excellent. E to the negative x means 1 over e to the x. Can we write it like that first? See, L'Hopital's rule is great when you got this fraction going on. That's not a fraction. Boy, it'd be nice if I could pull L'Hopital's rule. We're saying, yeah, just pull this where? So I'm just going to write, not an h yet, just rewrite this. Then I think we can do L'Hopital's rule, unless you already know what the answer is by just looking at this. Anybody already know who's growing at infinity faster?
E, denominator.
Do you have a sense of the answer?
So 0.
Gosh, I love it. Well, that's going to help you out. You'll find that very handy, not only in the next test, but the final. That means you get good sense of limits. Seriously. You're like, that's going 0. But I'll crunch through all of Lopi, okay? It's going to take me about 4 steps, though, because what's derivative x to the 4th?
4x cubed.
Jess, I still got variables. So e to the x, e to the x. Do it again, I get what? Still got variables. I still got variables.
24x.
Finally, I get 24 over e to the x. What's 24 of an infinitely large number?
0.
You wouldn't have to show all that work. Evan, I didn't finish this section. Okay? We're going to do more of this tomorrow. But can I do that dude I was talking about? Can I do the x over 1x? Can I do it now? We're going to keep doing these. I want to make sure, you might be like, I got this stuff down. And we know what always worries me? When you're on the test and I throw this at you in a problem, and a student misses chain rule, right? So tomorrow I'm going to start with a couple more of these. What's the derivative of tan of 4x?
Secant square 4x 4.
Times a
4.
right. Cool. So I'll throw some more at you at this. You might come in tomorrow and go, can you number 55 from 4.4 or something? You might have me do a problem from 4.3. But I wanted to end today with number 61. All right.
61.
This is bizarre looking. You know why? It's one of these guys. Something like that. We've only seen like one of these before. We did something called logarithmic differentiation. Do you remember that?
Mm-hmm.
And we're going to do something very similar. It's been a while. It was in this section where we learned implicit differentiation. I know. And it was something like this. So you might be looking at this going, I can't remember when we did this guy. We're going to do number 61, Josephine, and this is what it says. Hey, does anybody want the page number?
308.
Oh, thanks, Art.
No problem.
We're going to end on this guy. X goes to infinity of x to the...
1 over x.
Now the author talks about more indeterminate forms of this sort. If you want to memorize it, everyone, you would see this on page 306. The author calls it, ready? Indeterminate powers.
Mm-hmm.
If anyone wants to look at it, he calls it. So if you want to go, I want to memorize all the indeterminate powers. In this case, everyone, if you substitute infinity, what do you get? X to a what? X to a 1 over infinity. Now you might say, well, that's approaching 0,
Mm-hmm.
but that's approaching also what?
Infinity.
Infinity. So this is why it's indeterminate. How fast is this approaching what? 0, as this is approaching Infinity, this is what we call an indeterminate form. Okay? So you go, well, how the heck are we gonna play with this? How are we gonna play with this? We're gonna use a trick like we did before. You know what helps? Is when we can somehow turn this into a log. Because with logarithms, there's a cool property of logs. Like if I had this, I went in math, natural log of 5 squared, I can do something with that too.
Bring the 2 in the front.
I can move it to the front. And so you and I, this is what's bugging me. There's a variable up in the air in the exponent. So this is what we're going to do. We're going to start out and do this. Let's say, now whenever we do this at the beginning, we got to come back to this at the very, very, very end, okay? Let's say we actually had to do this. The natural log of x to the 1. And find the limit as x approaches infinity. Okay? And you're like, Professor Muster, what are you doing? You're changing the problem. Don't worry, I'll come back to this at the end. But I'm going to look at this, the natural log of x to the what?
1 over x.
All I did was draw in what at the beginning? Can you do that? Yeah, as long as at the very, very, very end, I'll come back to it. Okay? So let's make a little reminder. Don't forget. Don't forget when we're done to come back to it. Come back, okay? Don't forget we're going to come back to it. You go, why did I do this? I think you all know. What can I now do with this thing?
Bring it to the front.
Right in the front. And then we can apply this in. Let's check it out. So when I do that, x, 1 over x times what?
Natural log of x.
What's another way to write that? ln of x over x. Let me write that. So this is the problem you and I now have. Well, this is cool. That's approaching infinity. That's approaching infinity. This is going to be easy. Let's apply L'Hopital's right now. So I'll put my equals, I'll put my h there. Would you differentiate this? And just like you said, Ben, then I can put that limb down again, right? Ben was pointing this out. He goes, every time you do L'Hopital's, you really should write this every time. Did you notice I wasn't, though, all class? Because I don't mind when students don't do it either. As long as you know to always what? Substitute that number at the end. Now, what's the derivative out of x?
1 over x.
What's the derivative of x? Oh. So let me write this again. What's the limit as x approaches infinity? Whatever x. 1 over a million, 1 over a trillion, 1 over a quadrillion, that's approaching what?
0.
But, before you think this is the answer, and remember we go, that's it, that's the answer to the problem. Don't forget something. What did we do at the beginning? Hold on. What did we insert at the very beginning?
Let's.
An ln. So we got to reverse that. And you go, what reverses it?
Oh, so ln of 0.
Who's
so
his inverse buddy?
1.
Who's his inverse buddy? E. So did you know in math, e to the ln of blah is just what? I always forget how to spell blah. How do you spell blah?
BLAH. Is
Okay.
equals to E.
Is that right? All right. What's e to the ln of blah?
E. Blasters.
It's just blah.
Uh-huh.
All right. So can I give it? What's e to the ln of 2? 2. What's e to the ln of amber? Amber. Right. This is what we're saying. E to the ln of x, x. E to the ln of y is y. So you and I did this at the beginning, right?
Uh-huh.
We threw this ln, so now we got to reverse that. Well, we know that e to the ln of x to the 1 over x will just be the original function. So for our last final step, so we don't forget, and we didn't, come back, what was this number?
0.
I need you to put e to that number. That will be your answer. This is my last step. This is what you always do. You go e to the, whatever you just got here. And you go, why? Because e to an ln of what? Of this puts it back to this. So what is the answer to this problem?
1.
It's 1. I didn't forget. So this is what you do. You go, okay, if I ever want to do this like concept, just remember at the end, e to whatever you got, right?
Couldn't you tell it would be 1 though, since the exponent is approaching 0?
You know, that's good. You, once again, you got that number sense. I like when you can see that stuff. You know, from the beginning. You have knowledge, you can see stuff in the math problem. So very good. Excellent. Excellent job. Hey, everyone, great job with this. Like I said, we're not done with 4-4. I wanna come back tomorrow and hit with you a few more, okay? Have a great day.